When we're dealing with two samples in hypothesis testing, we have two situations. We can have two samples that are dependent samples, or our two samples can be what are called independent samples. So we're first going to look at the independent samples, okay? So when we have independent samples, it just means there's no relationship between the values of the two distributions. Whereas the dependent samples, there is a relationship. Oftentimes it's a before and after situation, okay? All right, so with the independent samples, we're going to set up the null and alternative. We can have three types of tests, just like we had on the one sample, okay? So this time we're comparing the means of two distributions. So a left-tailed test would be that mu1 is less than mu2. And then, of course, the null would be the complement there. Okay? A right-tailed test would be where mu1 is greater than mu2. And, of course, then the null would be the complement with the equals. Or we could also have the two-tailed tests. And this is where mu1 is not equal to mu2. Okay? So, very similar to what we did before. If we know our population standard deviations, we use the two-sample z-test. If we don't know them, we use the two-sample t-test. And if we have proportions, we do the two-prop z-test. Okay, then our critical region or the p-value method are the same, and I think most of the problems in Newton are going to use the p-value. We have our decision and conclusion. Okay, so let's look at an example here. A professor at a community college claims that a college algebra student can change his or her score on tests if the person is provided with a pretest the week before the exam. To test her theory, she selected 16 college algebra students at random and gave these students a pretest the week before an exam. She also selected an independent random sample of 12 students who were given the same exam but did not access to the pretest. The first group had a mean score of 79.4 with a sample standard deviation of 8.8, and the second group a sample mean of 71.2, standard deviation of 7.9. Test to see if the population mean score of students who get a pretest are different from the population mean score of those who do not. All right, so let's write down the information we know here. The students that had the pretests. Okay, that's going to be my first sample. Okay, and those we had 16 students. Okay, and they had a mean score, so that's x bar 1 of 79.4 with a sample standard deviation, so that's S1, not sigma, of 8.8. And not the pretest then, it's 12 students. So that's N2. And they had a mean, x bar 2, of 71.2 with a standard deviation of 7.9. All right, so what I encourage my students to do is write it like this. This is the people with the pretest. This is the one that did not. Now, when we read the question here, test to see if the population mean score of students who get a pretest are different from the population of those who don't. So really what we're testing is if it's different is just not equal to. Okay? But if we're testing if one's larger than the other, it's easier to write them beside each other and then point to the one that's going to be smaller. But not equal to is just a little bit easier here. Okay, so let's state the null and alternative hypothesis. So the alternative is what we're testing over here, that mu1 is not equal to mu2, and then of course the null is the complement of that. Now some books will write this mu1 equals mu2 as mu1 minus mu2 equals 0. Same thing though. All right, our test statistic then, the question is, are we using a z or a t? We're not using proportions because we have samples and means. Are we using a z or t? We are going to use the t because we do not know sigma 1 and sigma 2 are unknown. Okay, so we're going to use a t-test. Okay, and we're going to put in the information we have here. All right, so if I go to Stat, over to Test, I'm going to go down to, oops, too far, to Sample T-Tests. Okay, I have the stats, so I hit Enter. Let's scoot over just a little bit here. My sample mean is 79.4 for the first sample. Enter. Standard deviation is 8.8. Enter. And my sample size is 16. The mean for the second sample, 71.2. Enter. Standard deviation of 7.9. Enter. And my sample size is 12. Okay, and this is just what I'm doing with the alternative. And, oops, sorry about that. My alternative here is that mu1 is not equal to mu2. So I'm going to select that one. Do I pool them or not? If we assume the standard deviations are equal, we can pool them. This is similar to what we did with confidence intervals. We're going to assume they're not equal. And we're going to calculate. So I get a t-test statistic of 2.59. And my p-value equals 0.0158. Okay. So with the p-value method, we're going to reject the null if the p-value is less than or equal to alpha. Alpha was 0.05. So the question is the p-value 0.0158 less than or equal to 0.05? Remember, you can put the zeros here and just compare the numbers. 158 is less than 500, so the answer is yes. When our answer is yes, we reject the null. If our answer was no, we do not reject. So at the 5% level of significance, we either do or do not have enough statistical evidence. Since we rejected, we do have enough statistical evidence to conclude that now again, I kind of go back to the problem and look for that word that. Oftentimes it'll say do the data indicate that. This one says test to see if the, and this is what I'm testing right here. Population mean score of students who get a pretest are different from the population mean score of those who do not. So that's what I'm finding evidence of. So conclude that the population mean score of what I have highlighted here of students who get a pretest is different than those who do not. Is different than, or is different from the population mean score of those who do not. Okay, so there was enough statistical evidence to show those means are different. Now, she may have wanted to test if it was larger than the other one, but that's not what we had in the problem here. Okay, the critical region method, which I'm not sure I gave you homework on this, but it's very similar to the one sample. Since this is a two-sided test, two-tailed test, we have to find the positive and negative critical values, and then we see where our test statistic falls. Okay, so our degrees of freedom, there's a formula for it, but in this book, they use the smaller of the two ends. So this would be 12, so our degrees of freedom would be 11 in this example. And so we look at that table. freedom 11, alpha equal to 0.05, two-tailed test, I get 2.201 and negative 2.201. So when I draw in my test statistic, 2.59 is going to fall right here. So it does fall in the rejection region, which is consistent with my p-value approach of rejecting H0. Make sense? Okay, let's look at another example here. This is where we're dealing with two proportions. So very similar to what we did with the one sample and our two independent samples here is with means. Okay, we can have the same situation where we have three different types of tests, only dealing with proportions. All right. Last year, a random sample of 200 new car deals showed that 56 releases. The rest were sales. An independent random sample of 200 new car deals this year showed that 68 releases. Test to see if the proportion of cars leased this year is greater than the proportion that were leased last year. Okay, so let's do last year and write our information here. We had a sample of 200 and our X was 56. We have no means and no standard deviations. So this year, we had a sample of, again, 200, and our X was 68. So the question here is, test to see if the proportion of cars leased this year is greater than the proportion that were leased last year. Okay, so even though it says greater than, it's a little tricky because you want to know if this year is greater than. So I'm pointing to the smaller one. Okay, just a little tricky how you set that up. So my alternative is going to be that proportion 1 is less than proportion 2 because I set last year's up as my 1. Okay, the null then is going to be the complement of that. My test statistic I'm going to get from the calculator. So I go to stat, test, 2 prop z test because we're dealing with proportions. X1 is 56. N1 is 200, X2 is 68, N2 is 200. My alternative right here is less than P2, and I hit calculate. So Z is negative 1.30. If I round to 2 decimal places, just be careful what Newton asks you. P-value is 0.0973. All right, I'm going to go ahead and go down to the p-value approach. So we're going to reject H0 if the p-value is less than or equal to alpha, which is 0.05. So my question is 0.0973 less than or equal to 0.05? Think about it as 500. So no, it is not. Therefore, I do not reject H0. Make sense? Remember, if we say no, then it's do not, which means at the 5% level of significance, we do or do not have enough evidence. That's right. We do not, remember the nots go together, not, have enough statistical evidence to conclude that, and then we go back up to see what we're testing. The proportion of cars leased this year is greater than the proportion that was leased last year. The proportion of cars leased this year is greater than last year. The proportion of cars last year. Okay? Make sense?